For the explanation of the code on the exercise 1, firstly we declare the variables red LED, yellow LED, and green LED, which correspond to the digital pins used by our LEDs. The LDR pin is for the analog pin connected to our light sensor. The last variable is light threshold, which defines the minimum light intensity that the sensor can detect in order to trigger a method. In the setup function, here we set the red LED, yellow LED, and green LED to output mode, so we can manipulate their voltage to turn them on and off. Below that, we set them to low, which means they are initially off. In the loop function, we place an if statement to check whether the sensor detects light or not. Depending on the light detection, the corresponding results are set, each with its own delay.
Low, 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 low.
For the explanation of the code on the exercise 2, firstly, declare the variable sensor to represent the analog pin that reads input from the sensor. The variables LED1 to LED5 represent the digital pins connected to the LEDs that we will be using. The level variable stores the sensor reading, which could represent the intensity of the sound frequency. The different threshold variables are constants that define the sensor levels that we'll be using in the if statement's conditions. Inside the setup function, we set the pin mode of all digital pins LED1 to LED5 to output, allowing the program to control the voltage and turn the LEDs on or off. In the loop function, we first assign the level variable with the sensor reading. Then, we set all the digital pins to low to reset the LEDs at the start of each loop. For the if statement, the sensor value is checked against different thresholds. Depending on the value, a specific set of LEDs will light up. If the value exceeds the highest threshold, all LEDs are turned on. As the value decreases and falls within the lower threshold ranges, fewer LEDs are lit. If the sensor value is below the lowest threshold, all LEDs will remain off.